Hey guys, so here's the Unit 1 test review. We'll be focusing on the short answers today. Let's take a look. For your response, short answers, it says show all the work and graphs should be neat and labeled. So you need to have it labeled. Number 1, let's get started. It says identify the parent function for each description and state its features. Domain, range, intercepts. 12 points. So part A, 4 points. Rapidly increasing and never touches the x-axis. As we've mentioned earlier in class, this is the exponential function. Now for the exponential function, you can also write it as y is equal to b to the power of x. Now why was it b? It's b because this b represents base. Now what's the domain? Before I give you the domain, let's do a quick sketch of what an exponential function looks like. So we have x-axis and y-axis, and any exponential function is going to have a 0, 1, most. And going from there, we also need to have a asymptote at y is equal to 0. So this is going to be the x-axis. So that's going to be the asymptote, the line that the graph approaches but never touches. And then we can graph the exponential function that rapidly increases and never touches the x-axis. So the domain, as you can see, it's going to be all real numbers. Range, does it include the x-axis or no? No, it does not. So it's going to be y is greater than 0. Now the x-intercept, because the graph never intersects the x-axis, there's going to be none, and the y-intercept is going to be 0, 1. Now for part B, let's take a look. Part B. We see a U-shaped graph with vertex at origin, symmetric about y-axis. Now let's again do a quick sketch of a U-shaped graph. The vertex is going to be at the origin, right? So what is this? What does this look like? It is a quadratic function. Now for the quadratic function, you also may have written y is equal to x squared. That's absolutely fine. And as you can see, it's all real numbers for domain again. But range, it includes the 0, 0. Therefore, it's going to be from y is greater than or equal to 0. Now the x-intercept is going to be the origin, and the y-intercept is also going to be the origin, 0, 0. Moving on, part C. V-shaped with a sharp corner at the origin. Now, at the origin, there's a sharp corner. Then, oops. What does that look like? It is going to be an absolute value function. So you can also write it as y is equal to absolute value of x. Now the domain, it's all real numbers. Range, again, it includes the origin, so it's going to be y is greater than or equal to 0. Let me go make that change. Y is greater than or equal to 0. And both the x-intercept and the y-intercept is going to be at the origin, 0, 0. Now for number 2, describe the transformation applied to the parent function f of x is equal to absolute value of x to obtain g of x is equal to 2 times the absolute value of x plus 1 minus 3. 16 points total. And let's take a look at part A. Part A, list them in order. So with any transformation, we've talked about how g of x is going to be a times f of x, f of bx minus h plus k. We are going to start with everything that's closest to the x value. So first off, you're going to multiply b. What is this? It's going to be the horizontal stretch or shrink by factor of 1 over b. So that was the very first one. And then what's after that? Next to the x bx is going to be the h. Now this h is horizontal or vertical shift. Again, it's going to be the horizontal shift. So that's number 2. And then after this, you have to multiply the a. Now when we multiply a, it's going to be the vertical shift. So number 3, vertical shift, vertical stretch or shrink, excuse me. Vertical stretch, shrink. Now, some of you may be curious. Now, Mr. Kim, what if it's a negative value? If it's a negative value, the order doesn't matter because let me give you an example. The negative, it's going to be a reflection in the x-axis. Now, if you multiply -2 times 3, let's say, what is -2 times 3? Is it we multiply 2 times 3 first, and then it becomes -6? Or can we just do the multiplication and just come up with -6? So this -2, the example, we don't separate the sign with the number. So it's okay to do whatever that comes to your mind first. You can multiply the negative, or you can multiply the coefficient. And then lastly, we have the k value, number 4. It is the vertical shift. Okay. Let me rewrite that. Shift. Now, part B says let's sketch it. So let's give it a try. So we're going to start with the HK. -1, -3. So you have to label it. So -1, -3, because those are the HK values. And then we have the slope of 2. So we go up 2 units. So 1, 2, and then to the right, 1 unit. Now, in class, I've mentioned this briefly, but let's review before I sketch this graph completely. Now, let me get this. All right, let's. Now, for each of the increments on the x-axis, we have 1, 2, 3, and we have -1, -2, -3. So is the distance between each increment identical? Is it uniform? Yes, it is. So we can have it like that. In the x-axis, we have 1s. How about the y-axis? Again, it's going to be 1, 2, 3, 4, 5, and then it goes down, -1, -2, -3. Now, are the increments also uniform? Yes, they are. So if the increments are identical, if they are uniform throughout all the axes, then this is absolutely fine. So we go from, let's go back to the question now. We have increments, a slope of 2. So we go up, 1, 2, and then 1. All right, we have that. We can go the other way as well. 1, 2, it's a reflection because there's a, what is this called? It is the axis of symmetry. So symmetrical on the right side and the left side. So we can go ahead and graph this. So that's going to be a graph for g of x. But because I'm teaching you, let's take a look at f of x. So f of x, the parent function, we're going to start from the origin, and we have this here. So using the increments here, it looks much more broader than g of x. Now that's clearly the case because f of x has the a value for f of x is 1, and the a value for g of x is 2. So 2 is going to give us a vertical stretch. Okay, let's move on. All right, number 3, quadratic functions, 12 points. We're given y is equal to x squared minus 4x plus 7, and part A tells us to convert the given function to vertex form. Now from standard to vertex form, what method do we need? We need to use the completing the square method. So let's begin. Y is equal to x squared minus 4x, and then we have plus 7. Now, I'm going to separate the first two terms with the last constant because we need a third number to complete the square for x squared minus 4x. Now, in order to do that, we know that we have to identify what the b value is, -4. What's b over 2? -2. And what's b over 2 squared? It is +4. So we're going to add that +4 inside the parentheses. And to maintain equivalence, we have to again subtract 4 outside the parentheses. So it's basically the same equation. Now, once we do that, let's take a look at how we can factor x squared minus 4x plus 4. For the x squared minus 4x plus 4, let me use a different color pen. I'm just going to isolate x squared minus 4x plus 4. We're going to factor this as, yes, you have it, x minus 2 squared. So we have x minus 2 squared, and we can rewrite the original equation as y is equal to x minus 2 squared. And then what's 7 minus 4? It's +3. All right. So we have this converted equation in vertex form. We have x minus 2 quantity squared plus 3. That's the answer for part A. Let me write it here at the top. Y is equal to x minus 2 squared plus 3. And I'll get rid of the information. All right, let's continue on with part B as I am erasing this work. Now, part B, it says, identify the vertex, axis of symmetry, and direction of opening. So what's the vertex? Vertex is always going to be HK. Now, the H value is 2, and the K value is 3. Okay, amazing. So we have that answer. We have 2, 3. And what is the axis of symmetry? Axis of symmetry is going to be x is equal to h. So my axis of symmetry is going to be x is equal to 2. And then what is the direction of opening? So the A value, A is greater than 0. So the direction of opening is upward. There we have it. That's part B. Now, part C, explain how the graph transforms from the parent function, parent quadratic, y is equal to x squared. So to make it clear, let's write it. So y is equal to x squared. That's our parent function. And we have a given function in vertex form, which is y is equal to x minus 2 squared plus 3. Identifying what this 2 value is and 3 value, they are both shift. So we have a horizontal shift to the right 2 units and vertical shift 3 units up. So that's how you would explain for part C. Right 2 units and up 3 units translation. Let's move on. Question number 4, we have piecewise function. C of x is equal to 10x when x is less than or equal to 2. And C of x is equal to 20 when x is greater than 2. Let's start with A. A, for the piecewise function, which represents cost in dollars for x items, graph the function over x between 0 and 4 inclusive. Earlier in the other graph, we have to identify the margins first. Now we have 10x and 20. So for these, why don't we have 10 as our y-axis margins? So we'll start with 5. So let's write it 5, 10, 15, 20, and goes on, right? 30, because there's the 10. And also for the 20, y should be equal to 20, so we need a 20. Now for the x-axis, we can just leave it as 1, 2, 3. So 1, 2, 3, 4, you can go on like that. All right. Now, how can we graph? For the 10x, we need to plot the points from 0, 0, 1, 10, 2, 20, and then for the negative, we have -1, -10. So you have that, we can graph it. Now for the 20, we have 2 is equal to 20, 3, 20, 4, 20, 5, 20. So it's going to be all of that from, and it's going to be greater than 2. So if you graph this, the boundary lines, it's going to look something like this. Am I right? And then, well, we have to change the graph because part A tells us to graph this for only between 0 and 4. So there we have it. So that's going to be your answer for part A. Now, how about for part B? Let's take a look. It says evaluate C of 2 and C of 3. So C of 2, when x is equal to 2, are we going to use the first one when x is less than or equal to 2, or the second one, x is greater than 2? It is equal to 2, so we need to use 10x. So 10x is 10 times 2, so that's going to equal to 20. So C of 2 is 20. Now, how about C of 3? Which one do we use? X is greater than 2 now because it's 3, so we just have 20. Oh, so both of them are 20. All right, then how are we going to interpret that? So in the text, it says cost in dollars for number of items x. So for C of 2 is equal to 20, we're going to write as it's going to cost $20 for 2 items. Now for C of 3, it's going to say also it's going to cost $20, but in this case the x is 3, so it's going to be 3 items. So that is going to be your answer. Is the function continuous at x is equal to 2? Yes, it is. There is an overlap between x less than or equal to 2 and x greater than 2. So the function covers the two values, the x value at 2. So it is going to be continuous. However, another way of explaining this is, do you lift your pen or pencil as you're graphing this? No, you don't have to lift your pen. So that's an easy way of identifying how continuous it is. Number 5, system of inequalities, 12 points. Graph the system of inequalities y is greater than or equal to 2x minus 3, and y is less than negative x plus 5. Shape the solution region and identify one point inside it using the test point method. So again, we have this, and we're going to keep the increments as all ones. So each point is going to be one distance away from the other point. Now we're going to start with here, 0, -3, because we have -3 as our y-intercept. So going from there, what's our next step? Our slope is 2, so we go up 2 units, 1, 2, and then to the right 1 unit. So we have 2 points there, and that's our graph, that's our boundary line for the first inequality. Second, we're going to begin with plus 5. So we have 0, 5 here, and our slope is negative. So we have go down 1 unit and to the right 1 unit. Therefore, it's going to be this here. Now my boundary line is dashed because there's no equal sign here. All right, going from there, now let me shift over. So greater than, so it's above this line, and less than, so it's going to be below the other line. So what's the overlap? The overlap is inside this triangular space where you can just shade this region here. All right, so that's going to be your answer. Now, again, it says identify one point inside it using the test point method. So what is the easiest point that you can find? 0, 0. So let's check 0, 0. If 0, 0 is the solution, let me find a lighter pen. 0, 0, is it the solution for both inequalities? Y is greater than or equal to 2x minus 3. And on the right side, let me again put 0, 0. Is it the solution for y is less than negative x plus 5? So let's substitute 0 greater than or equal to 2 times 0 minus 3. So 0, is it greater than or equal to 3? Yes, it is. So that's good. And then on the right side, 0 less than negative 0. So there's nothing as negative. So 0 plus 5. 0, is it less than 5? Again, yes, it is. So after you show this work, it just proves that this shaded area is correct.